Good morning, students. Let's continue with chapter number 13, Pythagoras Theorem, module 2. Dear children, we are going to deal with a topic called as Pythagorean triplet. Let's see what is Pythagorean triplet. A group of three numbers which satisfy the property of Pythagoras theorem is called as in Pythagorean triplet. These set of numbers can also represent sides of right angle triangle. So, lengths of sides of a right angle triangle are Pythagorean triplets. Example 3, 4, 5, 6, 8, 10, 9, 40, 41. All these sets of three numbers can be called as a Pythagorean triplet. Practice set 49. Question number 1. Find the Pythagorean triplets from among the following sets of numbers. Now, dear children, we are given a set of three numbers. We need to check whether the set of three numbers are a Pythagorean triplet or not. Let's see. First example, 3, 4, 5. Now, to check whether it is a Pythagorean triplet, we need to apply Pythagoras theorem. We need to check whether this set of three numbers satisfy Pythagoras theorem or not. Now, the property of Pythagoras theorem says side 1 square plus side 2 square is equals to hypotenuse square. Now, let's take up the square of two smaller numbers, that is 3 square plus 4 square. Now 3 square is 9. 4 square is 16. So 9 plus 16 is equals to 25. So the square of two smaller numbers will put up as equation number 1. Now let's take up the square of the bigger number or the largest number, that is 5. So 5 square is 25. We'll take up this as second equation. Now, dear children, just check what do we get from equation 1 and 2. Now we can see in equation 1, 3 square plus 4 square is 25, and in equation 2, 5 square also is equals to 25. So from 1 and 2 we can write, therefore 3 square plus 4 square is equals to 5 square. So we can see the set of three numbers, that is 3, 4 and 5, satisfy Pythagoras theorem. So we can write, therefore 3, 4, 5 is a Pythagorean triplet. Second sum, 2, 4, 5. Let's check whether it is a Pythagorean triplet. 2 square plus 4 square, that is the square of two smaller numbers. 2 square is 4, 4 square is 16. Let's add them. 4 plus 16 is 20. We can keep this as equation number 1. 5 square, that is the square of the larger number. 5 square is 25. Equation number 2. Now, dear children, observe equation number 1 and 2. 2 square plus 4 square is 20, and then 5 square is 25. Are they equal? No, they are not equal. So we can write, therefore, from 1 and 2, 2 square plus 4 square is not equal to 5 square. So, since 2 square plus 4 square is not equal to 5 square, so 2, 4 and 5 is not a Pythagorean triplet. Question number 1, sub-question 5, 9, 40, 41. Now we need to check whether 9, 40, 41 is a Pythagorean triplet or not. Let's go ahead. Let's take up the square of two smaller numbers. That is, out of 9, 40, 41, 9 and 40 are the smaller numbers. So let's take up the sum of their squares. So 9 square plus 40 square. Now dear children, tell me what is the value of 9 square? 9 square is, yes, 81. Now 40 square. 4 square is 16. So therefore 40 square will be, yes, 1600. So let's add them. 81 plus 1600. It's 1681. We'll put this as equation number 1. Now let's square the largest number, that is 41. 41 square is 41 into 41 and its value is 1681. We'll put this as equation number 2. Now, you children observe the values of equation number 1 and 2. Yes, what we get, what we observe. Yes, their values are equal. So we can write, therefore, from 1 and 2, 9 square plus 40 square is equal to 41 square. Now, since 9 square plus 40 square is equal to 41 square, that is, these numbers 9, 40, 41 satisfy Pythagoras theorem. So, 9, 40, 41 is a Pythagorean triplet. Let's move towards the next sub-question. Sub-question 6, 4, 7, 8. Let's check 4, 7 and 8 is a Pythagorean triplet or not. Yes, dear children, now you will tell me what is the first step. And the first step, yes, we need to take up the sum of squares of smaller number, two smaller numbers, that is 4 and 7. Now 4 square plus 7 square. Let's see what is the value of 4 square. Yes, 4 square is 4 into 4, that is 16. 7 square, 7 into 7, how much it is? Yes, 49. So 16 plus 49 is equals to 65. This is equation number 1. Now let's take up the square of the largest number. Out of 4, 7, 8, which is the larger number? Yes, it's 8. So let's take up the square of 8. 8 square is, yes, it's 64. This is equation number 2. Now we need to observe equation number 1 and 2. Dear children, tell me, what is your observation? Are the values equal? No. So we can write, therefore, from 1 and 2, 4 square plus 7 square is not equal to 8 square. That is 4, 7 and 8. These numbers do not satisfy Pythagoras theorem. So we can write the final statement. Therefore, 4, 7, 8 is not a Pythagorean triplet. Now dear children, you need to solve Practice set 49, question number 1. That is all the sums which are solved in this video. I hope you understood how to identify a Pythagorean triplet. Thank you.